Imagine a creature that can vanish into the ocean floor in seconds. Not by hiding, but by becoming invisible. It's not magic. It's science, and it's happening right now, right beneath your feet. This is no ordinary sea creature. This is the octopus, a master of disguise, using a power that most animals can only dream of: optical camouflage. These chromatophores are like tiny living pixels, each one able to expand and contract to create a perfect mimic of its surroundings. It's not just about blending in. It's about outsmarting predators, confusing prey, and even communicating with fellow octopuses. This is the cold open to a journey into the strange, stunning, and scientifically amazing world of optical camouflage and octopuses. So what exactly are we talking about? It's not just about octopuses changing color. It's about their ability to manipulate light in ways that make them invisible to predators and prey alike. This isn't a random color change. It's a highly coordinated, almost hypnotic display of light and shadow that mimics the environment around them. These chromatophores are just the beginning. There are also iridophores and leucophores that help reflect and scatter light to perfect the illusion. What makes this even more amazing is that octopuses can do this without moving. They're basically using their skin as a living, dynamic display screen. This is not just camouflage. It's a form of optical deception that blurs the line between the animal and its environment. You might think octopus camouflage is just cool, but it's actually a survival mechanism that could inspire new technologies. Their skin can change color and texture in milliseconds, making them invisible to predators and prey. This isn't just about color. It's about texture too. Their skin has specialized cells called chromatophores that can expand and contract to create patterns that match their environment. Scientists are studying these abilities to develop adaptive camouflage for military tech, robotics, and even medical applications like stealthy implants. Understanding how octopuses control their skin could also lead to breakthroughs in bioengineering and materials science, nature's own smart fabric. So while it might seem like an animal trick, octopus camouflage is a window into the future of technology, and a reminder that nature has already solved many of our problems. Back in the 1800s, scientists first began to notice how octopuses could change color in seconds. Their skin wasn't just reacting to light, it was actively computing its surroundings. Early studies showed they had specialized cells called chromatophores, which could expand and contract rapidly. This wasn't just color change. It was a full optical camouflage system. In the 2000s, modern imaging tech allowed us to see this in full detail. We now know the octopus isn't just changing color, it's adjusting texture, brightness, and even pattern to fool predators and prey. Today, this natural optical camouflage is inspiring new tech, like adapted camouflage for military gear and even digital displays that mimic the octopus's skin. From ancient seas to modern labs, the octopus has been mastering optical camouflage for millions of years. It's one of nature's most sophisticated visual tricks, and we're just beginning to understand it. Imagine you're a superhero, but instead of a cape, you have skin that changes color like a mood ring. That's what octopuses do, but way cooler. They don't just change colors. They match their surroundings perfectly. It's like they're wearing a superhero suit made of the ocean itself. Their skin has special cells called chromatophores that expand and contract like tiny balloons. When they do, they change color in milliseconds. These cells work with other cells too, like iridophores, which help reflect light and make the color shift even more amazing. So when we see an octopus disappear, it's not magic, it's science. And the best part? It's all happening in a blink of an eye. To begin, octopuses have specialized cells called chromatophores, which are like tiny color switches spread across their skin. These cells can expand or contract rapidly to change the color of their skin in milliseconds. Beneath these chromatophores, there are other structures called iridophores and leucophores. These reflect and scatter light, helping the octopus match the background texture and brightness of its surroundings. The octopus's nervous system sends signals to these cells via a complex network of nerves, This allows for near instantaneous color and pattern changes, adapting to new environments in just a fraction of a second. This entire system is controlled by the octopus's brain, which processes visual information from its eyes and compares it to the environment. The brain then directs the camouflage process with precision and speed. Once the octopus detects its surroundings, it starts the second phase, adjusting its skin to match. Special cells called chromatophores expand and contract, changing color and pattern in milliseconds. These chromatophores are controlled by muscles connected to the nervous system, allowing for fast and precise color changes. They can create patterns that mimic the environment perfectly. Together, these cells create a dynamic camouflage that can adapt to almost any background. The octopus can even change its texture to match the surface it's on, like a rock or coral. This process is not just about color. It's about creating the illusion of being part of the environment. The octopus is essentially a living chameleon, but with far more complexity and speed. The mechanism is so advanced that it blurs the line between biology and technology. Scientists are still uncovering how this natural system works at the cellular level. Once the octopus has adjusted its chromatophores, it's time for the final step in its optical camouflage. It uses specialized cells called iridophores to fine-tune the reflection and mimic the exact light patterns of its surroundings. These cells are like tiny mirrors, able to shift the way light is reflected across the skin, creating the illusion of depth and texture that static color alone can't match. This final adjustment is what makes the octopus's camouflage so convincing. It's not just about color, but about mastering light and reflection to match the environment perfectly. It's a sophisticated, real-time interaction with its surroundings, a living, breathing camouflage that evolves as the environment changes. At the heart of an octopus's camouflage lies a complex network of chromatophores, iridophores, and leucophores, each playing a distinct role in color and light manipulation. Chromatophores are the primary color producers, containing pigments that expand or contract to change the skin's hue in milliseconds. Iridophores reflect light in a way that creates iridescence, allowing the octopus to mimic the shimmer of the water or blend into reflected surfaces. Leucophores scatter light, providing a white or light background that helps the octopus blend into murky or brightly lit environments. This entire system is controlled by the octopus's nervous system, which processes visual information and sends signals to adjust its skin in real time. It's not just mimicry. It's a biological marvel of precision and speed, making the octopus one of the most sophisticated optical engineers in the natural world. Imagine a chameleon in a jungle, but instead of just changing color, it's also rearranging its skin like a painter mixing pigments. The octopus is doing something even more advanced. It's not just blending in, it's creating a visual trick that makes it disappear. This isn't just about looking like the background. It's about matching the exact lighting, shadows, and even the texture of the environment. It's like the octopus is wearing a suit made of the sea itself. It's not intelligence, not in the way we think of it, but it's a form of evolution's brilliance. The octopus is a master of optical camouflage, not because it's thinking, but because it's programmed to survive. So, in a way, the octopus is like a living chameleon, only more advanced, more precise, and more alien. It's not trying to outwit us, it's just trying to stay alive. Before you go, if you enjoyed this, please give it a like, and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.